Hello, this is video 27 and it's picking up where the previous video left off, so I'll put dots. We are looking at the recursive overload of the put function, the one that's doing all the actual work and finding out the position in the tree and putting in the new value. We did the base cases in the previous video. This is the inductive cases. What are they? Well, let me review what we know. We know that, oh dear, was it new item, new value? I think it was new value, I don't remember. Whatever that new data thing, the new value type item to be inserted was. I think I called it new value, but if I didn't, I'm sorry. We know that new value must be either, and I'll mix it up, either more or less than root arrow data at this point. We just don't know which it is. Oh no, what am I going to do? I don't know which it is. How about doing a test, an if test? Test is new value less than root arrow data. Is it less? Is it less? What does that mean in terms of what's going to happen in the tree? If it's less than, what we need to do? I don't know. I should have figured this out in advance, huh? If it's yes, put, well, this should be a comment, I guess. Put new value somewhere in roots, going back and being a little abstract here, in somewhere in roots left subtree. I'll put a colon because that's not really pseudocode there. That's just saying what we're going to do. I'll make that a comment. Is new value less than root arrow data? Did I even get that right? We're inserting cat. Cat is less than dog in all cases. So we're going to insert cat somewhere in the left subtree. Yes. So what we got to do is make our recursive call. Call recursively, a comment again. Since I got all this board space, might as well use it. Call recursively going left. All that buildup in there's really not that much to do. We call put. How do we go left? I pass in root arrow left. Which, for review, not to browbeat you with it or anything, but we're passing that in as this data type, a reference to a node pointer. What it means is we're passing in this node's left child by reference so that we can change the value of this node's left child pointer if we need to put in a new node. And pass in, we're doing a pass through with the new value. And I'll leave off the semicolon so that it's pseudocode rather than actual code. And you might well wonder, why did he indent all that much? I know he's big on indentation. Yes, I am. But remember, we're going deeper and deeper in the tree, wiggling left and right, and maybe left again, and so on. Eventually, we're going to hit the bottom of the tree if this is going to be a successful operation, and it's going to return true. We don't want to ignore the return value over here. We want to return. We want to take whatever this call to put returns to us and return that back to whoever called us. Pass back, pass back, pass back. Back over our head to whoever called us. So when this gets back, we will need to return the return value of put. Let me see if this even makes sense. Inductive cases. We know new value must be either more or less. In other words, it's not equal. We know it must be not equal to it. Test. Is new value less than a root data? If so, yes. Then let's put it in the left subtree over here. because that's where it belongs. It's less than the roots data. Recall recursively going left. Here's a recursive call to the recursive overload. We pass in root arrow left. We are lying. We tell the recursive put function that this is the root of the entire tree. And it starts all over again at the very top with the base cases and everything, thinking, well, someone gave me the root of a tree and wants to insert this data value in there. And we lie and lie and lie and lie over and over again, going further and further down the tree until we eventually hit an external node, also known as a zero pointer. When we do that, the base case takes care of it, makes a new node, and then it returns true to whom? It returns true to us. Returns true and said, you know what, you got a new left kid down there. Congratulations. It's a girl. And we put a new node at the left child, return true, and then this function, this recursive call here, does nothing but take that true value and turn around and send it back, perhaps to the public wrapper, perhaps to an earlier recursive call. We don't know. That's what I mean. It's a chain reaction. I'll put a comment down here. No. No. Put new data, whatever I called it, put new value in roots right subtree. I'll emphasize left and right here with double underlines. Since I'm not using multicolors, I have to use multiple underlines to make things really stand out, I guess. And how do we do that? Same thing. Return, put, root arrow right. New value. And that's a nice solid board full, isn't it? Is that it? I think that's it. If all of this made good sense, all of it, and you're up on your syntax, you're up on your recursion, up on node structures and pointers and all that stuff, this should be it. This should be it. The inductive case, since we know it's not equal, we know it's not external, then all we got to do is make a recursive call. This boils down to either going to the left or going to the right. All this words for these two statements down here. Either we go to the left because the data item we're inserting is smaller than where we are, or we go to the right. The hardest thing, and there's, I mean, I could keep making videos, I could keep talking over and over and over again. The hardest thing to get to sync through, and I'm aware of this, is just the recursive nature of this. This local view. Root for all this function knows, inductive cases, base cases alike, for all this function knows, what we just now got passed to us was the root of the entire tree. When we bottom out and hit one of the base cases, well, when we hit the first base case, when we hit a 0, when we bottom out, this function thinks every single time it inserts a new node, it thinks it's inserting the first node in the entire tree. And from that local point of view, it is, because the root of the entire tree is 0 by the time we get to the bottom. We tell bigger and bigger lies about smaller and smaller trees until we get down to an external node. That's the root of a subtree. It's an empty subtree. It's got 0 as its value. And this function, when it hits that case and puts in the new node, every time, it thinks it's putting in a new root of the whole tree. It's just amazing. And I wish you luck. I hope that works out for you well. And remember, I will be answering questions on get and the destructor and all the other stuff. I'll be doing that via office hours, and I'll probably even set up an extra class meeting for Zoom that you'll get an invitation to, and we can discuss it then. But I am not going to go through pseudocode and pictures and everything for all that. Some of that has to be left for you. This is CS3, by the way. I'll see you online.